You go to the Sea of Galilee, and it's one of these places where you're actually and literally looking at the same view that Jesus saw with his disciples.
Whether you are a Roman official in Tiberias, a tax collector at Capernaum, or a pagan over at Hippos, they can all see this beautiful body of water.
Israel hit a point where water loss meant national failure. To stop it, engineers forced seawater uphill into a mountain, burning energy to fight gravity itself. Massive pumps ran nonstop. We recycle 85% of the wastewater, which makes us a world leader in water reclamation. We can create agriculture in the south of our country with the water that's coming from this. Tunnels were sealed deep underground. A single failure could have emptied reservoirs and crippled cities. The system was rushed, risky, and built under extreme pressure. Yeah, it's an incredible story. We're here on the shores of the Sea of Galilee. People reconnect to a story that's been waiting for someone to find it for almost 2,000 years. But what happened after the pump started, what problem this plan was actually hiding, and why it nearly went wrong changes how this story ends. The vanishing lake for Israel, the most important freshwater source, sits in the north, the Sea of Galilee. It looks calm and small from a distance, but in truth, it is a working reservoir, the country's main natural freshwater store. Walk its shores today, and you see the problem with your own eyes. Where water once reached the trees, cracked mud, and exposed lake beds stretch for kilo. Old piers now, and hundreds of meters from water. Gauge poles painted with black and red lines stand like warnings. Each stripe marks a point where trouble starts. Drop below those marks and pumps, ecology, and human needs all begin to fail. The lake's importance comes from geography. It sits at the bottom of a rare natural catchment. Streams and the Jordan River, fed by snow on Mount Hermon and by winter rains, flow downhill into this single basin. It is the lowest freshwater lake on Earth, more than 200 m below sea level. So everything higher on the land tends to drain into it. For thousands of years, this made it a reliable source of fresh water. Rain and meltwater filled the lake each year. Springs added more, and people could use that supply. Modern Israel came to rely on that lake for almost everything. Pipes and pumping stations carry its water far to the south, to cities, and to farmland in dry regions. The system worked for decades, but the demand kept rising. The country's population grew and irrigated farming expanded into the desert. More water was taken out, and the water level fell slowly at first, then faster. At the same time, the climate changed. Winter rains became less steady, and snow on Mount Hermon less reliable. The natural inflows that once refilled the lake each year began to shrink. On top of that, rivers are shared across borders. Upstream countries developed their own water systems and took more from the Jordan before it reached the lake. So, the lake faced pressure from two directions: less water coming in from nature and more water being taken out by people. Those pressures show up in practical, damaging ways. Plants along the shore are dying. Fish and birds lose habitat. The exposed lake bed releases dust that worsens air quality. Engineers mark critical levels on poles because drops below certain heights cause real harm. Pumps can begin to draw air, not water, and then stop working. Pipes and intake systems are damaged. The ability to supply cities and farms is threatened. That situation creates a harsh choice. If water use keeps rising while the lake continues to shrink, the supply will fail. To avoid that, people must cut how much they take, change what they grow, or find new sources of water. Those options are not easy. Reducing use can hurt agriculture and livelihoods. Building new supplies like large desalination plants or huge reservoirs costs money and energy. Each choice brings trade-offs. The crisis at the Sea of Galilee is not a single event, but a long process made worse by several forces. Population growth, changing weather patterns, regional use of shared rivers, and a reliance on one main freshwater body. The exposed shores and painted gauge poles are simple signs of a deeper problem. The system that once supplied much of the country is under real threat. Facing that threat means making difficult decisions about water, land, and the way society uses both. The first miracle, conquering geography. Faced with that impossible choice, Israel's first answer was not to conserve, but to conquer, to bend the very geography of the land to its will. This was the 1950s. The country was young, poor, and bursting with newcomers. Its population was doubling. These people needed homes, and more than that, they needed food. But the fertile land was mostly in the north around that single lake. The south, the Negev, was a vast, empty desert, beautiful but brutally dry. The vision was as simple as it was audacious. If the people cannot all live by the water, then the water must be brought to the people. Thus was born the idea of a man-made river. They called it the national water carrier. The plan was to take the water from the north from that overburdened Sea of Galilee and send it on a journey south. It would travel through pipes, canals, and tunnels, across mountains and deserts to the very edges of the country. It was a moonshot project for a nation that could barely afford rockets. At the peak of the work, 1 out of every 14 working adults in Israel was on the project. They were digging trenches, welding giant pipes under the blistering sun, pouring concrete, and blasting through solid rock. The country was still scraping by, yet it spent a staggering 5% of its entire economy, its GDP, on this one system. It was an all-in bet on water. So, how does this artificial river actually work? It starts with a humble intake pipe submerged in the northern corner of the Sea of Galilee. The water is drawn in and held in a small reservoir. Then, it meets its first and greatest challenge, the hills. The lake is low, but the central mountain range of Israel stands between it and the south. The water cannot go around. It must go up and over. This is where the engineering heart of the system kicks in, the Sapir pumping station. Here, massive pumps roar to life, doing the primary heavy lift. They push that water straight up, a vertical climb of over 200 m in one go. This is the initial monumental defiance of gravity that the whole idea depended on. Once the water wins that battle and reaches the top of the ridge, the rules change. For the next stretch, it flows gently downwards through a huge open canal called the Jordan Canal, letting nature's gravity do the work. Finally, it is fed into a closed giant pipeline, a steel artery that snakes its way down the map all the way to the parched fields of the Negev Desert in the south. The transformation was nothing short of a miracle. Overnight, the map of Israel changed. The Negev Desert, once a barrier, began to bloom. New towns and communities sprang up, not around natural oases, but around water taps fed from the north. Agriculture exploded. Israel didn't just grow enough food to feed itself. It started exporting oranges, avocados, and tomatoes to the world. The Sea of Galilee was no longer just a lake. It became the literal beating heart of the nation. Every drop pumped from it was a pulse of life sent to the farthest corners of the country. The system was a triumph, a testament to human ingenuity in the face of nature's scarcity. Despite how impressive it was, the national water carrier had a serious weakness built into it from the start. It did not create any new water. It only moved water from one place to another. The entire system depended on a single natural source remaining healthy and full. That meant the country's water supply was tied to forces it could not control. It relied on winter rains in the north, melting snow on Mount Hermon, and the steady flow of the Jordan River. If those natural inputs weakened, the whole system suffered. The project solved the problem of moving water to where people needed it, but it did nothing to increase the total amount of water available. Demand kept growing while the source stayed the same. Over time, more and more water was taken from that one lake. In the end, the system that helped build the nation also put increasing pressure on its only major water source. The breaking point. For decades, the system worked. The heart kept pumping, but then the rhythm began to fail. The early 2000s brought the first major warning. A drought settled over the north. The lake level began to fall not just for a season, but year after year. It dropped over 2 m between 2000 and 2002. The country held its breath, and eventually the rains returned. Crisis averted, or so it seemed. But this was not a one-off event. It was the beginning of a new terrifying pattern. Another brutal drought hit from 2008 to 2011, then again from 2016 to 2018. Each drought was more severe than the last. The numbers became frighteningly normal. In a single bad year, the lake could lose over 80 centimeters of its depth. The national water deficit ballooned into the hundreds of billions of gallons. This is when those painted lines on the lake's gauges transformed from theoretical marks into national obsessions. The lower red line was the first major threshold. Breaching it meant the water quality would start to deteriorate fast, and pumping it would damage the lake's own ecology. It was an environmental danger sign, but the line everyone truly feared was the black line. This was the point of no return. Below this line, the salt concentrations become so high that the water is permanently ruined for agriculture. Even worse, the lake's intake pipes for the national water carrier would start sucking in air and mud, destroying the pumps themselves. It was an operational stop sign. Crossing the black line didn't just mean the lake was sick. It meant the entire national plumbing system, the country's lifeline, would grind to a halt. And as the water level fell, a vicious cycle kicked in. The lake wasn't just getting smaller, it was getting sicker. With less fresh water to dilute it, the natural salt springs at the lake's bottom made the remaining water saltier. This salty, stagnant water became a perfect breeding ground for toxic blue-green algae. The lake's vibrant ecology began to suffocate. The very idea of it as a strategic reserve was crumbling. Israel was now trapped in a textbook catch-22. The equation was brutal. To save the lake, they had to stop pumping from it. But to stop pumping was to cut off the water supply to homes, and most critically to the vast agricultural fields in the south that fed the nation and its economy. Letting the farms wither would mean economic disaster and food insecurity. Yet continuing to pump would guarantee the total destruction of their only major freshwater source. It was a choice between two catastrophes: paralyze the present or obliterate the future. This dire situation forced a complete rethink. The old logic where the lake was the sole source and the carrier was the solution had broken down. They realized a painful truth. You could not save the natural system by continuing to drain it as your main supply. The answer wasn't to pump less from the lake. The answer was to stop needing the lake altogether for everyday survival. To break this deadly dependency, they needed a new font of water, a source that was not at the mercy of the clouds or the snow melt or the politics of neighboring rivers. They needed to find a way to make water, not just move it. They would have to look west to the one source that never ever ran dry, the vast, salty Mediterranean. The Mediterranean Sea isn't just a stretch of water. It's one of the most famous, most important, and most fascinating seas in the world. The second miracle, creating water from the sea. Israel turned its back on the hills of the north and looked west to the glittering blue horizon of the Mediterranean Sea. An ocean of water right there. It was the ultimate paradox. A country dying of thirst, staring at a limitless, undrinkable sea. The monumental challenge was stripping the salt from it on a scale vast enough to supply a nation. To understand the scale, it helps to look inside one of these water plants. Take Sorek, one of the largest desalination plants in the world. It is not beautiful or dramatic. It is a huge industrial site filled with pipes, tanks, pumps, and control rooms. Everything is built for one purpose: turning seawater into drinking water. Inside the plant, the process used is called reverse osmosis. Seawater is pushed through special membranes at very high pressure. These membranes have extremely small openings. Water molecules can pass through them, but salt, minerals, and other impurities cannot. Those unwanted materials are separated and removed. What comes out is clean, fresh water that is safe to use. This process happens constantly, day and night, at an enormous scale. The plant does not produce small amounts of water. It produces water in massive volumes. A single facility like Sorek can generate more than 150 million cubic meters of fresh water every year. And of that, 150 million cubic meters are produced in Sorek alone. That's around 20% of Israel's domestic consumption. That amount is enough to supply nearly 1.5 million people. Running a plant like this requires a lot of energy and money. Powerful pumps are needed to create the pressure, and the system must be carefully maintained. It is not a cheap solution. It represents a major national investment designed to secure water supplies where natural freshwater sources are limited. This was the paradigm shift, the quiet revolution. It started with a single plant, a proof of concept. But seeing it work, Israel doubled down. They built another, then another, refining the technology and driving down the cost with each new facility. It was a deliberate strategic sprint to turn a novel idea into a national infrastructure. Within a decade, a chain of these industrial marvels was operating along the coast. By the 2010s, Israel wasn't just running an experiment. It was managing a network of 5 colossal water factories, all humming in unison. The result was a fundamental change to the nation's plumbing. Almost overnight, the source of the water in Israel's taps changed. The majority of the water flowing to homes, schools, and businesses in Israeli cities was no longer siphoned from the struggling lake or the overstressed underground aquifers. It was manufactured on demand from the sea. The ancient, anxious link between the kitchen tap and the winter rain clouds was finally severed. The nation's drinking water was now on a production line, immune to the moods of the sky. This was a monumental victory, but it was not the final one. The Sea of Galilee had been given a reprieve. It was no longer the main source for drinking water. The pressure was off, but the lake was not yet saved. A huge amount of water was still being pumped from it for agriculture to grow food for the nation and for export. The lake was still losing more water than it was receiving. The rains were still failing, and the Jordan River was still a trickle. So while the immediate crisis for households was over, the lake itself continued to shrink. It was still slowly emptying. The problem had been made smaller, but it was not fixed. After years of shrinking water levels, Israel's Sea of Galilee is inching near the black line. Israel had created a new source for homes, but the ancient lake was still being used to water the farms. They had secured water for their taps, but their primary natural reservoir was still in decline. They had mastered the art of making new water, but now they faced a new task: using that new water to rescue the old. The factories could supply the people, but a different plan would be needed to save the lake. The master stroke, the river that flows uphill. And so Israel arrived at its most radical idea yet. The desalination plants had freed the lake from supplying homes, but the lake was still dying, still being drained for agriculture. To truly save it, they couldn't just stop taking water away. They had to start putting water back. But how do you refill a giant lake when the rains refuse to fall? The engineers had their eureka moment. They looked at the 2 colossal systems they had built. On one side, the water-making machines on the coast humming away. On the other side, the national water carrier, that giant set of pipes and pumps stretching the length of the country. For 60 years, it had only ever flowed one way, south. What if they could make it flow backwards? This was the master stroke, the elegant synthesis. Connect the desalination plants to the old carrier system and reverse the flow. Use the country's own plumbing to send the manufactured fresh water not to the desert, but back north to the dying lake. They would turn a water-moving system into a water-restoring system. It was a breathtakingly simple idea and a fiercely difficult one to pull off. Reversing a system of this size was not like flipping a switch. The national water carrier had been engineered for gravity, for a downhill journey from the highlands of the north to the lowlands of the south. To send water back the other way meant fighting physics itself. It required new pumping stations, massive upgrades to existing infrastructure, and a complete rethinking of how the entire network was controlled. Engineers had to calculate pressure changes, energy loads, and water quality issues across hundreds of kilometers of pipes. Every mistake could ripple through the system. But slowly, piece by piece, the impossible became real. New pumps were installed, control software rewritten, and test flows began. For the first time in its history, parts of the national water carrier pushed water north instead of south. Desalinated water from the Mediterranean began its journey inland, climbing uphill through pipes that had never carried water that way before. This was no longer just water management. It was water choreography on a national scale. Then came the historic moment. Fresh, manufactured water reached the Sea of Galilee. Not rain, not river flow, but water made by human hands, released deliberately into an ancient natural lake. Israel had done something no country had ever done before at this scale. It had begun actively refilling a major freshwater reservoir using desalinated seawater. The lake was no longer just surviving on what nature allowed. It was being supported by technology. The effect was gradual but profound. The water level stabilized. Then, slowly it began to rise. The red lines of crisis were no longer being crossed year after year. The ecosystem, stressed and fragile, was given breathing room. Fish populations recovered. Salinity levels were controlled. The Sea of Galilee was not returned to some mythical, untouched past, but it was pulled back from the edge. This marked the final transformation. Israel was no longer a country waiting on rain. It had become a country that could decide, within limits, how much water it needed and where that water should go. Natural sources were protected, not exploited to collapse. Technology had not replaced nature, but it had shielded it. The lake that once held the entire nation hostage to drought had become part of a balanced system. The story ends not with abundance without limits, but with control, resilience, and choice. In one of the driest regions on Earth, a country proved that water scarcity was not only a matter of climate, but of decisions. And with enough planning, investment, and patience, even a river could be made to flow uphill, and a dying lake could be given a second life. This achievement sent shockwaves far beyond Israel's borders. Water experts, governments, and engineers from some of the driest places on Earth came to study the system. What they saw was not a single miracle machine, but a philosophy. Israel did not wait for one perfect solution. It layered solutions on top of each other. Desalination for supply, recycling for efficiency, smart pricing to reduce waste, infrastructure designed not just to deliver water, but to protect the sources that mattered most. One of the most overlooked pieces of this puzzle was wastewater recycling. While desalination grabbed headlines, Israel quietly became the world leader in reusing water. Nearly 90% of its wastewater was treated and reused, mostly for agriculture. That meant crops were no longer competing with cities or lakes for fresh water. Farmers irrigated fields with reclaimed water, freeing up clean water to remain in natural systems like the Sea of Galilee. No other country came close to this level of reuse. It wasn't glamorous, but it was transformative at the same time. Water stopped being treated as a cheap, limitless resource. Pricing reflected scarcity. Leaks were hunted aggressively. Pipes were monitored digitally. Losses that would be considered normal elsewhere were treated as failures. This cultural shift mattered as much as the technology. Water was no longer something that simply arrived. It was something that had to be earned, managed, and respected. The result was stability in a region defined by instability. While neighboring countries struggled with drought, crop failures, and political tension over rivers, Israel decoupled its survival from rainfall. A dry winter was no longer a national emergency. It was a data point. The system adjusted. More desalinated water was produced. Less pressure was placed on natural sources. The Sea of Galilee became a strategic reserve instead of a desperate lifeline. Fed by snow on Mount Hermon and by winter rains, flow downhill into this single basin. It is the lowest freshwater lake on Earth, more than 200 m below sea level. So everything higher on the land tends to drain into it. For thousands of years, this made it a reliable source of fresh water. Rain and meltwater filled the lake each year. Springs added more, and people could use that supply. Modern Israel came to rely on that lake for almost everything. Pipes and pumping stations carry its water far to the south, to cities, and to farmland in dry regions. The system worked for decades, but the demand kept rising. The country's population grew and irrigated farming expanded into the desert. More water was taken out, and the water level fell slowly at first, then faster. At the same time, the climate changed. Winter rains became less steady, and snow on Mount Hermon less reliable. The natural inflows that once refilled the lake each year began to shrink. On top of that, rivers are shared across borders. Upstream countries developed their own water systems and took more from the Jordan before it reached the lake. So, the lake faced pressure from two directions: less water coming in from nature and more water being taken out by people. Those pressures show up in practical, damaging ways. Plants along the shore are dying. Fish and birds lose habitat. The exposed lake bed releases dust that worsens air quality. Engineers mark critical levels on poles because drops below certain heights cause real harm. Pumps can begin to draw air, not water, and then stop working. Pipes and intake systems are damaged. The ability to supply cities and farms is